Ooh. All right. Hello, everyone. Welcome to a wonderful Monday. We've got a great partner with us today. We have Fred Patton from Auth0 to kick off a wonderful Monday morning or evening, depending on where you're from, and give us a fantastic tutorial on building an AI assistant in TypeScript with Auth0 and Vercel. Go ahead and take it away.
Hi, everyone. Hope beginning of a great day or the end. However, so today we're going to talk about building an AI assistant. But by assistant, we really mean an agent because we're going to have tool calling and all of that. So we'll basically go through some slides, then have a demo, and then look at code. So often, and I'm guilty of this, generally, security becomes an afterthought, and it's like, almost like a necessary evil. But when it comes to AI agents, it's actually much more essential than it often is. So you can think of it as, security is the floor, but once you have that floor set, you're actually able to do a lot more things. If you go back and think about RAG, right, and large language models, it starts with they can do all these amazing things based on this huge corpus that they're trained on, right? And so whatever you ask them, they're able to draw on that knowledge and give you an answer. And then we got into this retrieval augmented generation arms race where you had all these basically competing models, and the whole deal was, okay, how can we leverage information outside of um, of the training data, like for my organization? How can I do the same kind of things with my organizational data that the models do with what they're trained on? And so you have all these methods to inject that context at the last minute, and hopefully you're dealing with access and making sure people aren't seeing organizational data that they shouldn't see. And of course, that's a big issue. And that's that phase. And now we have, with tools, it really enables users to be able to have the agents do things on behalf with their own applications and the data associated with those applications. And now, because we know how easy it is to um, game or trick agents and how stuff can be stolen, and a lot of these apps can involve money, can involve source code and various types of sensitive information. We don't really want to trust an agent to be able to do whatever we can do, right? Because they do make mistakes, and those makes mistakes to be costly. So you need that guarantees. And so this is why I say enablement is the ceiling, because once you have some security foundations uh, taken care of, then people can trust those agents to do just what they want them to do and not all these other kind of things. And then even if someone tricks that agent to do something, you can trick an agent, but you can't trick, a security token. You can't trick a certificate. So that's the whole idea. So um, let's move forward with conventionally. We've done things with just uh, tokens, right? And client secrets and all these kind of things. And those are great until they're stolen, because once they're stolen, it's like cash. You can do whatever you want with them. So we want to also see what we can do beyond like the standard bearer token if we have certain applications like finance applications, medical ones, or all sorts of wide-ranging applications really want added security. And so there's a notion called sender constraining tokens. And so these are really tied to a specific device. So you can go and you can actually steal one of these tokens just as you were doing before, or if you were a bad guy. But now it won't work because it depends on a specific identity sending it. And so though you have it and you can make requests, those won't be valid unless you're stealing a private key or something. So there's two main models of sender constraining tokens. There's the old one, MTLS, which is right there in the transport layer. And then there's DPOP, which is basically demonstrating proof of possession. It's kind of what it stands for. So at the layer, MTLS happens during the connection handshake, while DPOP happens inside the actual data request. You're basically putting things in the header, so it's much more lightweight. So from a complexity standpoint, MTLS requires a certificate authority, X509 certs, while DPOP just needs a client to generate a simple public-private key pair on the fly. So pretty flexible there. They're both still have their places. So browsers struggle with MTLS certificates, and as we look at that a little bit later. So that's a pretty heavyweight solution that doesn't work well for things like single-page applications, whereas Depop works easily in JavaScript using standard web crypto APIs. So, we talked about the difference in layer, transport layer versus application layer, complexity. MPLS is high, requires PKI certificates, whereas Depop is just standard JWTs and key pairs. MTLS is best for server-to-server, confidential clients where you don't have to worry about the eavesdroppers within your secured network, while Depop is good for SPAs, mobile apps, public clients. Now, MTLS is a nightmare when it comes to, the web applications, where you go through the load balancers because that transport doesn't carry over. And so that was a big motivating factor for Depop, which enables end-to-end, it's able to survive the TLS termination. So MTLS is a bit more secure because it operates at the transport layer. You can think about it as with MTLS, it's gating you at the door, whereas with Depop, you can actually get through the door, but now they're checking you when you're at the counter. MPLS, because you're setting it up in that handshake, you pretty much do the heavy math just once, and then you're doing super fast operations going forward. Whereas, so it's a little less overhead than with Depop, where you're still on each client kind of generating your key pairs. So how do we actually use this? Looking at the Auth0 APIs for you're basically just going to turn on Depop, set Depop to true, put your callback URI, and then of course you're going to show your domain and client ID. And so once you've done that, each new session is going to start using it. And any pre-existing session will continue to use the standard bearer token. So sometimes you might want to basically force them to log out and log back in if you really wanted everyone using it immediately, kind of thing. And using it, basically, it's modeled after fetch. So this would pretty much look familiar. Some funny business with the Depop nonce ID that basically sets up a slot where you're going to be storing the server. It's going to be storing the server nonce for particular APIs. So you just kind of indicate what API it's going to do. You create the fetcher. And then after that, you're pretty much in familiar territory where you've just got a basically an auth-enabled fetch, and it's taking care of things for you underneath. Here's a look at it using Axios, since many of us would be familiar with that. And so it's just almost the same thing. You're putting in your handler and everything looks as before, but here again we see the fetch with auth where it allows you to basically let the system handle the um, you know the key pairs for each request. Every request is actually going to have uh, a specific uh, key with it. So there's it protects you from replay attacks. Now, if you need to use timeouts, then because fetch doesn't have that support, you could use abort signal. So here in this case, we're just basically adding that parameter for aborts signals and setting a timeout. And this works, but if you have static request parameters, then this won't work for you because basically this will have already happened. And so it's just going to immediately time out when you go forward. So for that, we can work around it by just adding a thin wrapper. So here, when we're creating the fetcher, we're specifying fetch here. And so now this is just going to be like the callback. So it won't have already run. And then when you run it later, it will operate as usual. And we can also use it, supply, maybe we have multiple APIs, and so we can specify different relative URLs and have a base URL, of course, for that. And should you pass in an absolute URL, it's just going to ignore the base URL in this case and just go with what you passed in. So the main thing is that everything looks as familiar as possible, yet you're using a much stronger level of security where if someone actually steals that token, it won't be enough. And in some cases, you may already have an access token. And so there's a way to specify get access token method and allow you to basically be able to support cases where you're still using the bearer token or you already have the access token. So you're basically, the system is normally going to call get token silently, which would already before you, but if you already have it, then you want to use the one that you want to use there. So before we get into the demo and the code for the demo, it's based on Auth0 for AI agents, and there's basically 4 key things that it enables you to basically add more capabilities to your agents. First, we start with user and agent authentication. Now that agents are tool heavy and they're going to be doing things on behalf of users, we really need to make sure that the agent is talking to the right person. And also you might have cases where you want to make sure the agent is talking to the right agent. And so, that's fundamental because I don't want to connect my accounts and have someone else accessing them. And then there's Token Vault. This is actually what enables you to have the connected accounts. And the big deal here is that instead of handing your credentials over to your agent, and so that they can make a mistake or a bad actor can kind of prod them to do things that you don't want them to do with your data. What Token Vault does is that it doesn't share those creds with the agent. Instead, it basically, when the agent needs to do something, it hands out short-lived scoped credentials. So basically, it's not letting you do all the things that you could do with that app. It's letting you do specific things that you authorize and for a limited period of time, so that over time, the agent just can't go ahead and accumulate all your credentials and then basically have root access for your data. Async auth then is how we handle this, basically just-in-time authorization. So let's say I want you to send an email for me. Now we don't want the agent to, we don't want to have to, just like an app, we don't want to basically authorize the agent to do whatever it wants with all our kind of information, and then for as long as it wants. So what happens is that when the agent is ready to do certain tasks, and it doesn't have access currently, it can basically have a push notification maybe sent to your phone. You have all the context, you're seeing what the agent is trying to do, why, you get full context, and then you can approve or deny. And if you approve, the agent can proceed. If you don't approve, then even if it tries, the it won't be authorized to do the operation, and so it won't be able to move forward without your okay. And then there's fine-grained authorization. So we've heard lots of cases where access control and people are pulling the wrong data, and all sorts of cases like that. So what fine-grained authorization is about is, instead of just having these very broad permissions like engineers or this department or managers or something like that, sometimes based on your model and your use cases, it's you want more control. Like perhaps a person can have access to resources when they're on a company network, or and maybe only during office hours. Um, so, or maybe you can do certain operations only when there is some preceding operation, say like some kind of breach or some kind of IT issue, where then it makes sense to do these things with massive users. So all those type of things can be handled with fine-grained authorization, even basically approving certain MCP tools. So very important. So for the platform, these are basically the four kind of pillars to have control of your application. So we talked about secure and controlled access, auditability as well. Sometimes things go wrong and you need to unwind or figure out what happened. If you have to roll it back, or even just figure out what happened and deal with it. So to do that, you need to know what agent is running, if it's doing, what user it was doing something on behalf of, who it got approvals from, all those type of things. Agent identity and delegation type things, like, for a tool to do something on your behalf, and personalization. And not just personalization as previously, where you're just looking at your conversational history, but really, since now you have users connecting their external apps and their data, is that whole new level of personalization. So the same type of wide range, and these are just a few of ways of authenticating users are available. So it could be username and password, which you probably don't want, because if you're going to be focused on giving tool use, you'll probably want, a social login or corporate SSO type thing. And then, we won't get into machine-to-machine authentication so much, but the delegated authorization, as we're kind of hinting at, is when you need authorization at the last moment, which is good, because that means that if anyone owned your agent and took control of it, they wouldn't be able to do the certain things because they wouldn't have this authorization. And so you want to basically unlock that authorization as late as possible and for as little time as possible. So just to recap, the AI needs to know who I am. AI needs to call behalfs on behalf of users. They need async confirmation, authorization, and they have to consider permissions, including very fine-grained permissions. So that, in a nutshell, summarizes what Auth0 for AI agents provides. So we'll just quickly look at a typical flow for calling APIs on users' behalf. There's a user auth that happens where you can get the access token. That is given to the agent, so it's not the full creds. It's just, again, short-lived scope permissions. Agent can make the tool call. It can get forwarded along. API validation and will happen, so you can get the response, and then everything moves forward. And Token Vault is really the main feature that we're going to be looking at, because it's what allows you to connect all these user applications to the agent in a controlled way. So it handles the token management, maintains user context so that we're really sure what user the agent is talking to and doing something on behalf of, and keeping things seamless. Maybe you logged in with Slack and you don't want to have to go do an auth for every tool involved. So that's part of the seamlessness, where it's able to basically utilize your linked and connected apps, and then we can have enhanced security by, again, protecting those credentials. So in connecting accounts using Token Vault, this allows, again, you to link those third-party apps. So when using those accounts, Auth0 acquires the tokens from the upstream identity providers and stores them in the vault. It does not ever give those to the agents, as we've been discussing. Instead, they'll get the short-lived scope tokens that they can use to access third-party APIs. And we're going to look at some of that code here, where when we're going to protect them with Depop for that, basically that added security. So we're going to have to configure an audience, basically which APIs are going to be valid, and it's going to need to be able to configure it to use refresh tokens, even multiple resource refresh tokens, since we're going to use it to grant access tokens. This is it's an Auth0 thing, but every platform basically kind of needs its own way to do that. So here's how we enable Depop. To connect to the Token Vault, we're going to, as before, we're going to set Depop to true. We're also going to set MRRT to true. It's going to use the multiple refresh tokens enablement. Use refresh tokens also needs to be true. And then we're going to create that Auth0 client. And now it's going to be able to not just use Depop, but use Depop with the Token Vault. And so when you're logging in, now this is how we would do it. We can basically call the login with redirect, specify our audience, specify the scopes. Remember, it's not going to have all the credentials, so it's got to specify which scopes, and if the user hasn't authorized them, they will get the out-of-band push notification on their phone, so that they see what capabilities are being asked about them regarding permissions, so they can affirm or deny. And then we can handle basically the redirect callback on login and move forward. So it's just a little bit more extra steps to be able to get so much more protection. Now, yes, I think I doubled that. Sorry about that. So let's jump in. Let's look at the demo, and then we'll jump into the code. So without further ado, we will. So Okay, so here I am. It's going to be a AI assistant, and again, to be able to do things, it's got to know who I am. So I'll start by logging in, and for it to be able to use my apps like Gmail, I'm going to want to use a social login, and I'm going to use my demo account, freeloader, don't judge me. And okay, so here's one of these consent screens that we see all the time, where now it's going to let the user know what kind of things you're trusting the agent to do on your behalf. So here it's talking about viewing my email messages and settings, managing drafts and send emails, view all events on your calendars. Okay, we're not going to actually click any of those. We're just going to proceed and not grant anything at this point. So, so first thing I see is that, yeah, it knows my test account name, freeloader. It says, hello, freeloader. I'm your personal assistant. How can I help you today? And here it's actually showing the avatar for my demo account. So we see it knows who I am. Maybe what information do you have about me, I can ask. So it returns the result. Okay, so yeah, it's got the profile picture, the email address, the nickname, name, and we see the result. It called the get user info tool. So it's not just the LLM pulling some context from some vector store and doing its best to give the answer. It's actually giving a tool that calls the API that has all the valid, real information. So it returns my user ID under the sub and all the details right there. So much more reliability when dealing with AI. Um, and various tools are being used. So some tools are non-sensitive. You don't have to authenticate with them. It could be something simple as a calculator. It doesn't matter if the agent is using a calculator for me, for you, or anyone else. So we could basically have it calculate something, and we'll see what that looks like. And it really doesn't need to know who I am at that point. So 2 times 4 plus 7 is what? Now, we know LLMs are kind of notoriously bad at math sometimes, though they do amazing things. In this case, well, actually, it actually just did it itself. Calculate this expression. Times 28 divided by 4, say plus 7. It should use the tool, so we want to make sure that it's going to comply. Okay, it's being a smarty pants right now. That's fine. It normally will use the calculator tool. I guess I'm being too easy on it. We'll just move forward. Let's just maybe search. What is the latest news out of San Francisco today? Okay. So it's doing a query. We see it's calling the SERP API tool. And so it's put in the query, and then it's got the output. We see all the JSON here, and then it's able to answer. So we see it didn't just guess, but it basically used a web search. And this web search it's using is based on having a typical API key, as we'll see later. Okay, all well and good. Let's have it do something more real now. Well, first, let's do this. Show me my Slack channels. Now, I don't actually have Slack for this demo account. Slack's not particularly cheap. So it's calling a tool to list the Slack channels we see, and it's going to ask for my authorization. I don't actually and that's kind of also why we didn't authorize anything initially. This is the case where we're seeing things get authenticated just in time. Okay, very good. Let's jump to one more thing here. Write an email to thoughtpoet@gmail.com with the subject, how's it going today? And the message, wow, the Chiefs are out of the playoffs. Okay. And before we do this, let's actually go peek at the email to make sure there's no smoke and mirrors happening here. Okay, so this is where we are. And now let's see if the agent can do this for us. It's gonna, remember we didn't give it permission. So here it wants to do a tool call using the Gmail draft tool. And so here's all the context, but the problem is I never gave authorization. We skipped that. So let's do that now. Okay, I'm gonna say okay with my account, and I'm gonna continue, and then I'm gonna continue. And now we can see what I've just consented to. I've now given permission for it to manage drafts and send emails. Okay, and now it says that it was able to, it handled the interrupt. So we see continued interruption equals true. It now allegedly was able to draft the email. Let's go see if that happened. We refresh. Oh, drafts. Let's be in the drafts. Yes, there we go. How's it going today? Wow, the Chiefs are out of the playoffs. Sent at a minute earlier. So in a nutshell, that's the gist of it. There's a lot of other kind of things that the demo source code does. Let's jump in now to the actual code. So we have a repo, and it's been listed in the channel. That's called Auth0. It works with a bunch of different frameworks. So if you're using Python or Typescript, you know, we've got you covered. And this is basically showcasing the token vault with how you can do basically tool access, async authorization, how you can basically keep the user in the loop and accept the just-in-time granular permissions. Of course, we needed the user auth. We glossed over the fine-grained authorization in the demo. As you saw, there is stuff for documents and doing that type of stuff. But we're just going to jump in and look at how we did what we just did. So one of the things you might notice if you're looking at the code is a lot of the stuff is kind of hidden and underneath because of the integrations. So a lot of times it looks like you're just using the tools that you are using kind of in a normal way. That will be clear as we look at some of those related examples. But let's jump in and look at auth first. So that auth client that we've been looking at, enabling Depop, doing all those different things. In this case, in the standard demo, it's not using that. It's just using, you know, some very simple setups. But here we're using the Auth0 client and retrieving the refresh token and retrieving the user, because of course the agents are going to be able to need that. So now when we look at what we're doing for the agent itself, we're using the AI-Vercel API. So, and then we're using those interrupts that we saw. We're using the Auth0 AI interrupts. And then what we just saw, we're getting the refresh token and the user. So when we did things like, oh, I should have demoed calendar, but whatever. When we're connecting the services, and specifying those scopes, we're using the API with Token Vault. And so for Gmail read, we have it doing with Token Vault, and we're passing in the connection. All the Google ones will always be Google Auth0, and then we're putting the specific scopes that we're enabling. Now notice this one here. It just has OpenID, and it just has Gmail read-only, right? So if we wanted to send an email, we wouldn't have been able to done it. We wouldn't have been able to do it. If we were searching our emails, which I hadn't shown, it would actually call this one, which is the least privileged scope. So, and you want to run the least privileges, because if someone hijacks your token or your agent, then the blast radius is much smaller. They'll only be able to do what the currently authorized permissions allow them to do. So what we did is we did a write, and so that used the Gmail compose scope, and all of that kind of key rotation, refresh token type things are kind of handled underneath. So we just have to hand in what we were passed, and the platform deals with it. So that's very cool. Calendar, then we would have basically set it to calendar events to be able to see what events that we have, and also to be able to create events. Similar stuff for GitHub, Slack. Okay, I should step it up, and so forth. So that's the gist. Let's move to see chat here. Okay, so as with most assistants, they basically really just have some kind of prompt. It could be long, it can be short, and whatever the guidelines are, you're giving the language model to use. And so here, it's very generic. We're just saying, and you remember we saw Slack, we saw GitHub, we saw Gmail, all those different things. Here, we're not even mentioning any of that stuff. We're just saying you're a personal assistant, you're helpful, and we're telling it to, you have access to a set of tools. So we don't specify which ones. You must provide valid JSON arguments, always format tool call arguments with proper JSON. And so the nice thing is, because you have these tools and that metadata, and you've made them available to the agent, it's able to, just from the natural language, figure out which tools it needs to do a job and call those. And so in the case where we saw with calculate, for some reason it wanted to handle those on its own today, but typically it will notice that it needs to, it has a tool for that and it can use it. So we have the prompt, and then we're specifying our tools here. And here's that interrupt that we saw, where when the user hasn't authorized something, we need a way to be able to trigger that. And then we're also going to output the results of those agent calls. Okay, here we go. So let's quickly look at context doc. That we'll skip that. Okay, so with Gmail that we looked at, we're using the LangChain tools for creating drafts, searching email. We are using those handlers, those wrappers that we use to kind of specify the specific scopes that we want to enable for our application. And then setting up the Gmail params, and then we basically create the Gmail search object here. Now we're going to wrap it as a tool. So we're going to call the Gmail read that we have populated. We're using the Zod library to make sure that the schema is appropriately defined so that the agent will, so that the language model will call the tool in the proper way. And then we're passing a execute method so that it can actually invoke the tool when it needs to. And so it's going to be the same type of thing for the Gmail draft as well. Only the inputs change, and it's the same situation there. Calendar has a little more complexity because of all the date and time formatting, the locale and stuff like that. But we see that we are chiefly using the our with calendar wrapper. We're using the Google APIs to call it to have more control. And then we're doing the same type of stuff. We're specifying the input format. And here in our execution, when we get that access token, we are specifying which version of Google Calendar. We're getting the auth token. We're setting the credentials. And then we're using that calendar events to basically list out stuff from our calendar and doing all the formatting and stuff. And so basically, before these frameworks, it would, it's a lot more work to set up and manage all that stuff. SERP API, we quickly looked at. Here, instead of a particular user, there's no args to pass because all we need is the API key, and we can create a tool by showing the input schema as before, and then just run it. And this is how we're able to search the web in real time. We saw user info about how it knew stuff about my my account, my profile. So here it's just using fetching the user info and passing that context to the agent, so it can say stuff like hi freeloader and whatever type of thing. Maybe we can quickly show on the page. If you so yeah, we're able to figure out the session, and then so before I logged in, it said the login thing, and there's no personal greeting because it doesn't know who I am, and it's not going to be able to attach it to my tools. And so basically, we'll just look at that session, and if it doesn't have a session, we'll be able to pass that login screen, and then we'll be able to capture the user information. And probably, okay, I think actually that's it just now. This it's just a basic layout. So how about if we have any questions, I can answer those. Otherwise, what I could do is go back and demo some of the things I haven't maybe. So depends on how people are feeling. So are there questions?
We do have two in the chat. One of them being, are you going to share a potential GitHub repo of what you've been demoing? This is from Abia.
Yes, that's kind of what I shared earlier. It's the Assistant Zero demo. Do you have that handy?
I can go hunting. Yes, because you shared it with me.
Yeah, if you share all those, that's good. Yeah.
Yes, I can do that. Then we also have a question, same thing from Abia. Which AI model are you using? These are some of them are a little bit from earlier, which is why I'm like, I forgot we covered them.
Yeah, in this case, it's using ChatGPT 4, or it's using Mini. Let's actually just go take a quick peek. It's ChatGPT 4, so that's the gist of it. Yeah.
All right, links are posted, but any other questions? Maybe people are typing. We do have a bit of a stream delay from when we're recording here to when it actually makes it out.
Okay, while we're waiting for questions to come in or not, I've gone back to the demo and I've asked it if it can check my calendar for today. I never authorized it, as we remember, so it's asking me whether I want to do it, and it's telling me what scopes it will use, which is basically Gmail Compose, which we've already done, OpenID. So those it has, but the missing scopes are calendar events. And if we quickly take a peek at my calendar, there's nothing on here. So it's not smoke and mirrors. Let's actually create a quick event here. I am not cheating, you'll say, and we'll create that. Now that that's here, let's go back to our app and authorize. Set my user, continue, and yes, all good. So now I have the consent screen that's I'm giving permission to view and edit events on all of my calendars. Go for it. It's a demo account. Okay. And yes, please see if I have anything on my calendar for today. You see, I had created it at the last minute, so I'm really not cheating, you guys. Here we go. We have results. It used the Get Calendar Events tool, and it found one event because I just put one. Oh, yes, I'm not cheating. Time codes and everything, and the HTML link. Okay, that's cool. And then we can view event. We'll click that here. And yes, it has opened up the event. So yeah, that's nice. Use my calendar. We can close that, I think. I think I closed my app. Or maybe I'm opening a new window is probably what's going on. Yes. Anyway, yeah, so I think we're probably good. I can get back 5 minutes.
All right, then. Well, thank you very much for your time. It was a brilliant workshop. I unfortunately did get distracted because some other stuff came up, but what I did get to catch was your presentation, and that was a lot more than I realized I didn't know. And so now I'm like, oh, well, now I have more things to Google. So thank you very much for that. I'm sure folks in the chat are also appreciative of this. As a final reminder to folks, if you haven't checked in to the event, go right ahead and do so. And thanks so much to Fred for joining us for a great workshop. I hope you have a great rest of your day. And as you have questions, as always, our Discord has lots of active community members. The links are in the chat for the GitHub's repo for today, as well as the AI agents being used. And Fred, you did provide your LinkedIn, so if you'd like to connect with Fred, feel free. I'm sure he'd love to hear about what projects you've been working on, particularly using Auth0 or even building off of this workshop. Great. Then I think we are done. Have a great rest of your day, everybody.
Bye-bye. Thank you.